Sometimes the thing that you're really trying to do is push data into MetaSounds. It's kind of the thing that they said procedural audio would be really worthwhile to do and why we want MetaSounds in the first place. And yet when it comes time to actually try and do it, it can be a little bit confusing. Today, I want to walk you through a few ways that we can use just some basic booleans and integer variables or float variables to control things like the volume of the interior parts of a MetaSound, pass in some values to play different sound effects without needing to create new sound cue, new MetaSound, multiple arrays of stuff. One of the really common things is really needing to make new MetaSounds, new cues, new audio files for everything. You can kind of bundle the logic together. The way that I've started working on this, I have this nice little scene here from some fab assets of this provincial sort of building, and there's some elements here. There's just two, well there's three really, but two that we're going to sort of focus on. I have this little telephone, I have that little gramophone, and then I have some sounds just outside the window there. If I walk up to this phone, I can hit E and start hearing it ring, and I can also hang it up. And if I walk up to the gramophone, I can turn the volume up. Hear this spooky sound, which I'll talk about in a little bit, and turn it back down again. Right? And if you wanted something like a crossfading a sound source based on the distance, we can go through that too. The elements that we're going to be talking about, these phones and the gramophone, are comprised of a few elements, but predominantly, the blueprinting I've tried to keep quite minimal. The reason I've tried to do that is just to show you that it is sort of more about pushing sound into MetaSounds or pushing values into MetaSound. I do have this interact blueprint that's a parent, and just to show you that there's nothing really special going on in here, this is a parent class of the interactables that we're going to have. It just has a collision box so that it can fire, and it just has a widget, and then it just has text variables and an interact interface here. So there's an interface that just has a virtual function called interact. You don't need to care about any of this. It doesn't matter. It's just so that I could have pretty text instead of cubes. Now, when it comes to pushing values into MetaSounds, let's talk about that really quickly. There are a few ways of doing this, and it predominantly starts from when you consider, is it a blueprint variable or is it an input parameter? And when you try and adjust them, like set Boolean parameter, these numbers here, set Boolean parameter, set float parameter, and you find that nothing is happening, usually that's because the value that you're trying to change is not an input parameter. Now, if I look at this system here, and I have an input, so I have this trigger input parameter here, and then I have a state Boolean parameter as well, but they are all input parameters, and that's really important. And if I look lower down, I have an array of answering sounds, an array of hang-up sounds, and a single phone loop. And the logic itself is to say, hey, play the phone loop, or play the answer, or play the hang-up, right? And then we have a mixer that goes together. Now, the only part that we really need to avoid this concept of needing multiple Booleans and multiple flags, multiple like phone ring hang up, phone ring answer, phone ring loop, and having them as different MetaSounds, we can use a trigger parameter here. And this trigger parameter, if you just kind of open a new type, so if I hit this input plus, you'll see the type here. These types, one day I'll go through them all. For now, the thing that we really care about is this trigger. And trigger is a little bit like what you get for free when you're using the one-shot interface. So if you use the one-shot, which kind of comes by default in MetaSounds anyway, you'll get this on-play. And you're probably used to something like this, where there's like an on-play variable and it pokes around. But we don't have to use it that way. And if you've always used MetaSounds with on-play, well, get ready, because trigger parameters help you change that up. What I can use instead is I can have this little interact trigger. And if I click this little simulate button, I can pick some states and have it listen to it. And then all we're going to do is take the state, which is set by the blueprint. This is set by the blueprint because I want to talk about that inter-blueprint communication. And we say, hey, when we get that input parameter, if the state is on, great, play the phone loop, right? And also hang up the phone, right? And if it's off, then do the other one. The other thing that we're doing here is using that Boolean state variable to be a 1 or a 0 to turn up or down the gain on that phone loop. So the phone loop kind of always plays, but we are turning it up and down. If this was on and we check it as on, this is a really important point. Whatever you set your input parameters at will be what happens when they play. So if you are trying to tweak something, like you have an input parameter for pitch shift and you set it to like 12 and you're like, oh yeah, playing around with it and it sounds great. When you go into the game, it will be default 12. So be sure to go back to your defaults, flick them off, and make sure that they are sounding like you're expecting them to sound. So from there, yeah, we fire this input, we work out which one to play, and we trigger the phone loop. We start that up, we turn it on if it needs to be on, or we turn it off if it needs to be off. And in this instance, because I am managing the lifetime of this behavior in Blueprint, I don't have things like turning the sound off. So you might have some virtual limiters and things like that. But that's all there is to the phone ring. All we want to do inside the Blueprint is get this event interact, which might come from any place whatsoever. For me, it comes from like the widget in the parent, but it could come from anything. And we want to say, hey, set the phone opposite. So if it was ringing, then it's not, do that. If it wasn't ringing, then it's not ringing, so it is, so do that. We change the text, again, don't worry about what's inside that. And we set this Boolean parameter. Now this name needs to match exactly. I would probably recommend promoting it to a variable and putting it as const or something like that, but keep it nice and generic as well. Don't have it as like phone. You might have it state or switch or status or something like that, especially because it's a Boolean. There's also this execute trigger parameter. That's to say, fire it off, right? If I set it and then fire it, that's a different interaction to firing it and then setting it. They're going to be used in different orders. But it's a really, really useful way to alleviate some of the, I made 10,000 versions of every MetaSound. You can pipe this data in and use it as you like, keeping in mind that everything in MetaSound gets evaluated when the graph fires. So there is a little bit of cost if you do those enormous footprint MetaSound systems where there's like every material ever. They will all fire, and that's maybe not what you want. So have a think about what could be a parameter and what might not be a parameter. The other thing that I will say is that there are two different types of parameter interfaces. There's this audio parameter controller interface, and there is an audio component interface. Now the audio component, if I click off this and I click set parameter, I'm going to find two different versions of it. The audio component version of it is actually these parameters here, these default parameters that I could set to like whatever if I wanted to store some data on that, and they kind of precede the audio parameter controller interface. So the one that you're looking for is the audio parameter controller interface. So the other one I wanted to show you was this gramophone, where I have an event interact. We're going to update the volume value. This really just means I'm taking note of it. So I'm saying like, will we going up or down, and then increase it or decrease it so that I have like a banded kind of value. And then I want to check, have we gone past the settings? At the moment I just have like a really cheap little map where I just say like the value. I just didn't want to do a radial slider. Sometimes I get lazy, okay, geez. From that we want to work out if we're at 0, flip the direction. If we're at the max, flip the direction. That's all that logic does. Then we're going to set some text and we're going to go to the params. For the params, I'm just going to look through that map that we have, find the value. In this instance, I have a safe branch just because, you know, it's sort of beat into me at this point, but you don't have to do that. And we would have this set float parameter for the volume as well. Then when we go into the MetaSound, I have two different components here. One of them is this important little node, this trigger on value change. Now you can see my input parameters. I have a change trigger parameter, which is that one that's going to fire. And I have this volume is a float that we're going to pass in. I want to keep this MetaSound as kind of encapsulated as I can. The way that I do that is by dragging off an input parameter and writing trigger.
This is a knife.
Trigger on value change, right? Or trigger on threshold, something like that. And these allow you to immediately get a trigger event that I could then use to compare like, hey, are we at 0? We're going to want to play a minimum value sound, like the sound of the thing switching off. Are we at the max, right? And I might want to play a max value sound there. From there, the trigger is also just going to play the sound. I don't even stop the sound here. You might want to do some logic to stop sounds. And then when we start playing, I want to play this Claire de Lune asset and virtualize it. Fun fact, this audio recording that you're hearing is the first audio recording ever. It's on wax cylinders and it's Edison sort of mumbling a horrific melody, but you know, not horrific melody because I hate Claire de Lune, just horrific melody because of the wax degradation. But I digress. The only other part that I did want to show you, one other way to get sound data into MetaSounds, and that's using these interfaces. Now, a lot of the time people will calculate everything, like calculate the attenuation, and then push it into the MetaSound using those float parameters. You don't need to do that though. You can use the interfaces that will naturally kind of subscribe to these events. So for this, I'm using this add interface, and I'm using the attenuation interface, which you can see throws up a few more little input parameters. One of them is distance, right? And we have this distance, which is how far away we are from the object. And we are mapping that between 0 and the max range. Now, I'm being a little bit cheeky here in that I'm also actually setting the max range dynamically. If I look at this audio component here, we grab the audio component, we grab the attenuation settings, grab the attenuation, and we get this enormous struct because I had a vertical monitor and I thought, yeah, let's use it. And so we grab the fall off distance and we're going to pass that in. That's just so that I don't have like a magic number problem where someone changes the attenuation distance and then all of a sudden like my embeds don't work anymore. I want to kind of avoid that as much as I can. So instead what I do is I pass that in as a max attenuation. I just do that once on begin play. So it's not expensive. It's not something I'm going to be doing all the time. But the benefit is that when I map the range, then I get a clamped value of the attenuation. So it's sort of saying if the attenuation is 3000, attenuation is 1000, let's make the maths easy, then when I'm 500 units away, the value is going to be at 0.5, right? Whereas if I change the max attenuation distance in the MetaSound, I would have to keep tracking that because then, you know, suddenly design makes my player walk a little bit faster and then the distances need to be, you know, accentuated a little bit. This would handle that. We get a value that we can crossfade between a close and a distant source in this instance, where I have virtually similarly Western town things going on, but you know, I'm crossfading them, so as I'm sort of walking away from them, they sound a little bit different in different parts of the room, and I can add attenuation and occlusion and culling and stuff. If you haven't used interfaces, they're a great way to get data into your game, especially for elements like the viewing angle of things, if you wanted to pan around sources, or if you wanted to do the distance or the delta between two sources. So if you're looking at Doppler system, where you want to calculate the forward vector of the player versus the bullet, and you want to calculate the dot product to work out that distance, that can all be done within MetaSounds. You don't necessarily have to blueprint it. Now, this is a really handy way to get data into your blueprints. Hopefully I have shown you some things that got your brain ticking over, and thanks so much, and I'll see you next time.